Is this on? Oh, yeah. Hey, everyone. My name is Firat. Today, I'll be talking a little bit about future of NearDA, which we launched a couple of months ago officially, and data availability sharding, which is going to be the next step in NearDA's future. Let's see if this is going to work. Oh, yeah, that works. OK. So really quickly, what data availability is. Data availability is it's just data that is stored on a network. It's a principle that the data that is stored on a network should be accessible and retrievable by all network participants. It's very easy to understand. The problem is usually when you try to do this at scale. And today we're going to talk about how we can do this at scale and how we're planning to do this at scale. But before that, with Near's new vision, we imagine a world where we want to abstract the chain. We call it chain abstraction. We want to make sure that developers and users shouldn't be bothered by the different chain details, and users should get the same experience throughout their Web3 journey. What does that mean for data availability specifically? The chain abstraction vision is that apps should work just with all chains, onboarding should be seamless, and things like gas fees and bridging should be invisible to users. For them to be invisible, the gas fees should be very, very small, and it should be homogeneous across all chains. And data availability is something that can leverage that and can decrease the gas fees for all chains who are using this Alt-DA data availability platforms. What do we have for NearDA at this moment? The current state is that we just have a, so by the way, Near is an L1 network. So we're not just a data availability network, we're also doing execution, we're also doing consensus. But how we're trying to do data availability is we're just trying to get the data availability part out of the L1 and make it available for other L2s to deploy their blob data on Near. How do we do that? We have a blob store contract. It's just a contract on Near L1. We have a ZK-like client, which I'm going to be talking more in detail, which relays the data, the inclusion proofs onto Ethereum L1. We have a very lightweight RPC client that you can just push your blob data to Near. And how Near protocol stores your data and how it provides data availability is through the consensus on the receipts. We also erasure code these blob data and push it to the L1. So our motto is to make everything reliable, affordable, and secure at the end of the day. Oh, sorry. Oh, I don't think this is, I don't think you can see this. But this is a diagram of how things work. It's basically a rollup pushes their data to NearDA client, to the Near protocol, and then that gets picked up by the Near-like client, which is now a ZK-like client, and gets pushed back to Ethereum. And then the rollups can get their commitments and push it directly onto the Ethereum also. The current state is that we've been integrating with a lot of different partners, a lot of different RAS partners, and a lot of different rollup stacks. These are the names. One, Polygon CDK. Right now, we're working on a V2 version of it. I put it there just to make sure that everybody knows that we're working on it. But as you can see, we've been working with a lot of them, and we already have rollups that are running live. So why NearDA now? If you guys want to go ahead and check the actual costs of how much storing your blob data is on NearDA, you can go to nearmodular.com. It's a better product, but if you look into there, you can see that our costs are around 100K cheaper than Ethereum, directly posting on Ethereum, and around 30X cheaper than Celestia as far as we've checked recently. We have a protocol that has been up and running for 4 years around with 100% uptime, which is very, very important. Like our friends there at Vail, they've been trying to get a protocol up and running for a while. I know that they're working on a mainnet launch, but we already have a mainnet for a very long time with a lot of validators in it and secured by billions of dollars at the end of the day. And like I said, we have a lot of RAS and rollup partners that are working with us right now. It's very easy to integrate your rollup. It's literally just a blob contract that you can just push your blob data into. And like I said, we're working on constantly decreasing the cost of DA so that we can achieve that chain abstraction vision that we have. So the future of near DA in the short term, what we're trying to do is, like I said, we're trying to further optimize our contract on L1 so that we can get the blob data submissions gas fees even lower. We're working on also increasing the throughput. Right now, Near has 4 shards, and we're trying to go to 5 shards, which is in 1.37.0 release, which is in testnet right now, so it's very close, which will allow us to go to 20 megabytes per second throughput. And as far as I know, that is the highest throughput right now in all DA providers. We're working on a Near multi-chain DA Explorer. You can think about it as asking an explorer where my data is, where my blob data is, and then you can follow along from Near L1 all the way to Ethereum. We're working and we're very excited about our ZK Lite client, which is going to be providing DA blob inclusion proofs on Ethereum L1 contract, so that you don't have to leave L1 Ethereum to check if your data has been stored and if it's been stored correctly on Near DA. We're working on a very exciting project with EigenLayer, which is called Superfast Finality, that allows cross-chain rollups transactions using Near DA, which is also going to be leveraging Near DA, which will also make the cost very, very low. And of course, more integrations and rollups coming. We've been working with a bunch of different rollup providers, rollup as a service providers. And yeah, stay tuned for the announcements. Now, I want to talk a little bit about a very important part that nobody wants to talk about, which is the hidden costs, L1 costs, with ZK Lite client. So the problem is, even if you store your blob data on a DA provider, you would like to get assurance on L1 that your data has been stored correctly. And as you might know, Ethereum cold data is not as cheap as we want it to be, but we're working with Succinct right now to provide a ZK Lite client, Near ZK Lite client, that would also involve inclusion proofs of these blob data. And we've managed to get the cost of this. We did a test, and we managed to get the cost of this from, I think it's $15 million, more or less, to 2.5K for 1 year of data for ZK Sync. And we want to get it lower, but I think this is a very, very good price point for any rollup that wants to use Near DA and wants to get their inclusion proofs or any kind of proof on Ethereum L1 to directly interact with it. Like I said, we're doing syncing and inclusion proofs using Plonky 2, which is also something that we're excited about. Now, the fun part. What's going to happen next? Near Protocol has been working on its roadmap, protocol itself, something called stateless validation. What is important about this is that instead of all the validators keeping the state in locally, we're moving towards a system where chunk producers, which are part of the validator set that produces specific parts of the shards and sends them to the validator network, they will only send the state witness now, which means that only the parts that the state transition is made and parts of the try has been touched is sent throughout the network, which in return means that we're going to have very, very lightweight validators. And only a few validators will need to operate very expensive hardware. What does that mean for DA, and what does that mean in general? So decreased hardware requirements means more shards. More shards means more throughput. If you push this to an extreme, right now we have, like I said, 4 megabytes per second per shard, which is 16 megabytes. But if you can have n number of shards, then your throughput is basically n. More shards also means that there will be less amount of data that is stored on a single shard. What does that mean? That means that these validators can hold their whole state in their memory. So they don't have to hold any kind of storage, which gets the cost very, very low. If you push this to an extreme, one DA blob contract, so one rollup, can be just one shard. This means that running an in-memory lightweight RPC client, you can run very lightweight RPC client that would only track the shard that your data blob contract lives on. So what does that mean? The RPC can act as a validator without actually participating in consensus, because RPC nodes actually apply the chunks that are coming from that specific account of that shard. And it's all in memory, and then you can pick your retention period based on the rollup that you require. Fraud proofs require sometimes up to a week for data retention, which is very, very cool, and we're very excited about it, which means that instead of you depending on a statistical data availability, like data availability sampling, you can just do this and then immediately get mathematical proof and applied chunks on the shard to just get the data you want. But this is not just this, we have more. We just announced the next stage of Near protocol, which is Starsight. It's a ZK-centric sharding. What does this mean for DA? Is that I don't want to go too much into detail. If you guys want to know about this, you can go ahead and watch Bowman Wang's presentation that he did in NearCon. It's online. He goes very much into detail. But TLDR for us, for the DA, is that at the end of the day, consensus can run separately from execution in Starsight. And you don't have to rotate their validators. So there's no prescription for runtime for each shard, and since consensus only validates on the ZKP of state transitions, at the end of the day, you don't need the you don't need the execution. So what we can have is we can have specific DA shards without any execution, which will bring the cost even further down. We can have additional proofs of protocols, such as proof of availability or storage proofs, which we cannot do right now. We can do specific DA shard optimizations on storage layout. Right now we're doing Merkle Patricia trees, but we can go through Merkle trees and even go through mountain range trees, which will also get the cost down on the storage. And rollups can actively participate securing their own data. So rollups can run validators specifically for this DA shard, which means that as a rollup, you can come in and just run a validator and secure your data without actually also getting involved in any kind of statistical security primitives. And the furthest down the road, we can also introduce in-memory data availability sampling, which is something that is not available as far as I know. Our friends on the back are also doing DAS. Hey guys, and we're very much looking forward to also talking about with you guys and try to work together as a data availability industry, let's say, moving forward. So yeah, that's pretty much it. I'm very excited about the future, and thank you.